Hi, good morning, everyone, and Happy New Year. So we are back to the RaCEEs course. This is session 5, and we are going to talk about analysis and results today. And I'm co-running this session with Andy. I think most of you will know Andy, but Andy, would you like to reintroduce yourself?
Thanks, Valerio. Yeah, hi, I'm Andy Clegg. I work with Valerio at UPenn and at Midas on cost effectiveness elements of different pieces of work and in evidence.
Thank you, Andy. I'm meeting people in the room. 1 second. Here we go. So as always, I need to remind everyone that this session is being recorded and will be made available on the ARC No West Coast YouTube channel. If you have any questions about the recording, please let us know. And as usual, I would like to ask you if you have any questions on the homework from the previous session. You will remember that we asked you to fill in a table with the info on the outcome data, info on discounting from the economic evaluation you are assessing. Do you have any burning questions for now, or are you waiting for feedback? Just feel free to let us know. Okay, so as usual, feel free to contact your team lead if you have questions, if you're waiting for feedback. We are here to help you, and we will try to get back to you as soon as possible. Right, session 5. So we've done the methods. So session 2 was the key attributes of economic evaluation. Session 3, we covered the costs. Session 4, we covered the outcomes. And now we are moving to the results section. And we are going to talk about the base case and the sensitivity and subgroup analysis. And we are going to describe what these terms mean in a minute. And I just want to remind everyone before we actually start that the workshop, which is the last bit, the main important bit of the RaCEEs course, will be on Tuesday, 11th of March at the University of Central Lancashire in the Engineering and Innovation Center. We sent you a placeholder invite, I think, before the holidays. If you missed the invite, just let us know, and please respond as soon as you can if you haven't done so already, so we can organize all the logistics for that event. In terms of the structure of the commentary, we are now on the results. So we will talk about the analysis today, and then in the next session 6, we will talk a bit about the introduction, and also we will cover a bit the expectation regarding the workshop. So I will quickly introduce you to what we can expect from the workshop. In terms of today's session, the aim is to understand and describe the results from the base case, the sensitivity and the subgroup analysis from an economic evaluation. We will define these terms, so base case analysis, sensitivity analysis, and then I will quickly talk about effectiveness results and cost results. And then Andy will cover the incremental cost effectiveness ratio and willingness to pay threshold. So these will bring everything together, the effectiveness and cost results together. Then Andy will also cover the net monetary benefit, and then we will talk about the cost effectiveness acceptability curve and common types of sensitivity analysis. Right, so this is our usual diagram with the typical structure of an economic evaluation. We cover the costs, we cover the consequences in the last session, and now we talk about cost effectiveness together. So we bring everything together in this session. Right, typically in an economic evaluation, we have 2 types of analysis, a base case and a sensitivity or more sensitivity analysis. If you look at your paper, you might see a small paragraph for base case analysis and another paragraph for sensitivity analysis, depending on the format of that specific paper. But usually these 2 things are quite distinct, and the authors will make a point about, I'm now describing the base case analysis, I'm now describing the sensitivity analysis. With base case analysis, we refer to the results obtained from running an economic model with the most likely or preferred set of assumptions and input value. so this is really looking at things probably at the average, let's say, with the most likely preferred set of assumption and input values. And we will describe a bit more later on what we mean with this. Sensitivity analysis, on the other hand, we try to understand how the results deviate from those of the base case analysis when input values and modeling assumption are altered. So we try to move away from the average bit, let's say, and we try to see what happens if we modify the input values in a certain way to reflect what might happen in the real world. These definitions comes from the glossary provided by the York Health Economic Consortium. You can find the link here. I think we sent you the link to the glossary already in the past, but yeah, you can find the link here, and we can send the link to the glossary later on as well. Now, I'm going to discuss effectiveness results now. So we're going to use the paper on advanced Parkinson's disease, which we've been using during the course. With effectiveness results, we're really looking at how the intervention compare in terms of the clinical effectiveness or composite outcomes. And you will remember this distinction from session 4, where we describe, for example, how clinical effectiveness outcomes apply to cost effectiveness analysis, cost consequences analysis, and composite outcomes, i.e. QALYs, applied to cost utility analysis. So this is a table from that article on advanced Parkinson's disease. And table 3, you can see the base case results per patient over the model time horizon and cost breakdown. Now, we are going to look at the effectiveness results only for now. So we are going to look at the second and the third row. And in particular, you will see we got the QALYs, which is a composite outcomes, and the life years, which is a clinical effectiveness outcomes. The second column, you got intervention. The third column, you got standard of care. And you can see how the two compare in terms of QALYs and life years gained. For example, for QALYs, you got a bigger gain in QALYs for intervention, 2.82, compared with standard of care, which is 1.43. In particular, you got a positive difference of 1.39 QALYs. For life years instead, we got 10.64 life years gain with intervention and 10.28 life years gain with standard of care. Again, a positive difference in favor of the intervention. So just by looking at the effectiveness result, we could conclude that in this base case analysis, the intervention seems to be more effective. Is everything clear so far? Any questions? No problem, Ale. Okay, so I'll move to the cost results. So we are going to look at how the interventions compare in terms of total costs. And this will refer to what we learned in session 3. We're going to look at the same table, but this time we're looking at the first row, so costs expressed in pounds. And you can see, again, there is a difference between the two comparators. In particular, the intervention seems to be more expensive, like about £33,000 more expensive than standard of care. So we got that situation where the intervention is more effective, but at the same time it's more expensive. And we are now lying in the northeast quadrant. You will probably remember this diagram we discussed, I think, in the previous session, the cost effectiveness plane. And with this particular article, with this particular economic evaluation, we are now sitting in this quadrant, the northeast quadrant, where the new treatment is more costly, at the same time is more effective. So we got this trade-off between cost and effectiveness, and we need to make a decision whether we are going to accept the new treatment or not. And Andy will talk later about a particular concept, willingness to pay threshold, which will help us understand whether we can consider the new treatment to be cost effective or not. But just for now, it's important to notice we are in this quadrant. So we got a trade-off between cost and effectiveness. And this is quite common, because when we try to analyze a new treatment, that means probably the new treatment has shown some promise in terms of effectiveness. At the same time, it will bring about some cost in terms of, for example, training staff, buying new equipment, and so on. So there is common to find this trade-off between cost and effectiveness. Any questions? Okay, I think this is Andy's, so I'll stop sharing. Andy, over to you.
Okay. Is that okay, Valeria? Does that come up as?
Yes, just I think we need a presentation. Yeah, that's it. Great, thank you.
Taking a bit of time. Great, thank you. So as Valeria says, we're looking at the incremental cost and the incremental effect of the different interventions that are there. And the key thing is for people who want to make decisions and that can be at all sorts of different levels, to have some kind of measure that brings it all together so that they can decide, is this a good use of the money that needs to be used? And two of the ways of doing that, as Valeria mentioned, were the incremental cost effectiveness ratio, which is illustrated here, or the net benefit approach, which we'll go into in a little while. So the ISA is literally the difference in the costs divided by the difference in the effect. And the example here is a different example to the one that Valeria was talking about. And this is treatments for cystic fibrosis. And there are a number of different drugs that have been brought out. And this particular combination, which is called Orkambi, in which there was a comparison made. This was for an actual NICE appraisal of Orkambi versus what actually was used, usual care. So Orkambi plus usual care versus usual care. And they wanted to see whether it was a cost-effective use of resources. So this is the actual outcomes that they used, life years gains and QALYs, and then the total costs. And as you can see, there's a very small gain, incremental gain in QALYs by using the treatment, 3.45 QALYs, but a very big difference in the cost. So the cost went up from just over 300,000 up to over £1 million, which produced a cost per QALY of £218,000. And what we need to do is decide, is that extra cost used appropriate? You can use these for, as I say, for different outcomes, as Valeria mentioned earlier, of QALYs or life years gains. QALYs tends to be the one that's used because it brings in, as the previous sessions have shown, both quality and length of life within it. So it's trying to decide what is it a good use of money at £218,000 per QALY. Just to give you an indication, here's one of the ways of sort of you can compare them, which is using league tables. So as you can see, there's an enormous variation here between all these different types of interventions that have been examined. And back in the, it's probably in the late 90s, early 2000s, etc., people did put the different interventions that funders could pay for in league tables to see whether they were beneficial. But how do you move from deciding whether to put money into GP advice to stop smoking or into Orkambi, which is quite a number of times bigger cost per QALY, from £270 up to £218,000. And this comes through, just move the slide on. This comes through the concept of willingness to pay threshold. Now, as it sounds, it literally is of the people who just make decisions about how to use funding, how much money should they be willing to spend to gain one additional quality adjusted life year or whatever the outcome is associated with it. This can vary between different jurisdictions. So I think the World Health Organization has a suggestion that the threshold should be 1 to 3 times the country's gross domestic product per capita per QALY. In China, it's 0.5. So how should it be judged? Because it can be explicit or implicit by the decisions that are made. In this country, obviously, NICE dominates how decisions are made, and they don't explicitly say that these thresholds that are on screen now are the thresholds that decisions are made by. They tend to be the guidance that is used around it, which is effectively somewhere between 20 and 30,000 pounds per QALY for a standard form of treatment. For highly specialized technologies, it can be higher. They tend to say around 100,000 pounds per QALY, but it does depend upon the situation, the circumstances that hold with that particular condition that's being done. So there have been some specialized technologies where there's some acceptance of cost per QALY in the millions. And that's because the nature of that technology, the nature of the condition, it could be a treatment of last resort, and therefore it's seen as being an important decision to make to actually back it. So there's an enormous variety of decisions that can be made. So when you see often in the press about the fact of NICE refusing a drug because it's at certain levels but accepting other ones, it's because of these other kind of factors that they take into consideration around that particular technology. You know, is it innovative? Is there a large degree of uncertainty around the interventions and the analysis undertaken for the intervention there? The Scottish, similar sort of level, just to illustrate some of the factors there, the Scottish Medicines Consortium have a similar threshold of around £20,000, but they look at a range of factors in trying to decide whether to go above it or not, which are on the screen there. I won't read them through. These are the sorts of recommendations that NICE make. So they give themselves quite a lot of latitude around their decision making, because there's a lot of things to be taken into consideration, as I've already mentioned, and the political situation that each technology may be surrounded by. So ICERs, are they perfect? No, they're not perfect. They are often probably the most frequently used measure, but they can produce results that seem not nonsensical, but slightly unusual, and give opposite values. If you think about it, if there's no difference in the effectiveness, so effectively you had a 0, you'd have a QALY that was infinite within it. Just to sort of illustrate the two sort of variations you can get around having an ICER the same, if you look at comparison A at the top there, you can see that the standard intervention, the already existing one, has a lower cost. It offers greater benefit than the new intervention. Therefore, the standard intervention dominates and has an ICER of -10. If you look at comparison 2, it's the opposite way round. So the cost of the new intervention is less, but provides the same, or it provides greater effect, and therefore it dominates. And yet the ICER are both the same for the two of them. So it causes a certain amount of sort of difficulty around it. And if you think about that go back to the cost effectiveness plane that Valerio showed early, it means that the same ICER produced decisions that were in different quadrants, and therefore it makes it very difficult for anyone to make a decision associated with those. So a different way of looking at it is through the net monetary benefit. It provides an alternative to the ICER, in which basically you're taking into account the threshold itself, and you can have net monetary benefit or net health benefit associated with it. Net monetary benefit is probably the most frequently used, in which you effectively take the threshold and multiply it by the benefit you've got, and then take the cost away from it all in terms of the incremental change that's there. and you interpret it, that a positive suggests that it's probably cost effective, and a negative would suggest that it's not cost effective. Going back to the Orkambi example, you can see there that in working that out, it comes with a negative value of £684,000. So that would suggest it's not cost effective use, and therefore any interpretation of whether to actually approve it would have to be on other factors associated with it. This is a different example just to show how you can get into a slight quandary about these things. So this is a new screening tool for I think it was dementia, in which the study that was used produced very small financial differences between the two interventions, and very small quality gains between them. So if you look at it, it looks as if the new intervention, the ICA tool, dominates because it offers more at a lower cost. But there are very small figures here. So it's dominant. But then if you work out the net monetary and the net health benefit, it actually suggests that it isn't cost-effective use of resources of the two. I think that probably the reason for being cautious, going back to that league table, and the reason for being cautious is all the different types of analysis have so many different factors about them, which is what we'll be doing, going through the critically appraising them, that to look at these in context is important. So when you do the analyze the paper, etc., and the study used from it all, it's very uncertain, which creates this opportunity for a different decision to be made depending on which outcome you use. So it's really important to be the critical appraisal of the economic evaluation to be certain about the decision you're making, or the degree of uncertainty that is around it. I think we're over to you now, Valeria, aren't we?
Yes, thank you, Andy. Any questions? RaCEEs. Okay. Let me open the chat.
Hi, sorry. I've got one question.
Okay, good. Yeah.
Hi, Andy. Obviously we know each other. I was just wondering, one area where I think, obviously in my works, I work in suicide prevention. We have the difficulty sometimes is it's not easy to do your straightforward control and intervention group. So one thing we're looking at is whether we can do that comparison with primary care data for people who are using an intervention and people who aren't.
Mm-hmm.
Is that another way it can be done? But does the quali have to be completed by people completing a survey or something at time points, or can it be worked out?
So it depends on what your outcome measure is, because you can have a cost per whatever it is associated with the outcome. So if people aren't able to complete that measure, the EQ5D or other, to form the quality adjusted life year, then like in the examples, there was the cost per life year gained. You can have a cost per event avoided, etc. So you can come up with different outcome measures that are relevant to the particular intervention.
Okay, no, brilliant. That's really helpful. And something maybe to look into a bit more. Thank you.
We also have a question from RaCEEs. I'll just read it out. Which organization provides insights into which medical condition that they are prioritizing, NICE or the NHS, or both? Do they share annual reports, or do we have to do a systematic review, economic evaluations? I don't know, Andy, probably it's a collective choice there. Probably the Department of Health as well has got some say on which medical condition they're prioritizing. I don't know if you want to add something, Andy.
Yeah, so there's for NICE, obviously NICE is the organization that provides guidance and guidelines around which interventions to use in different situations. The prioritization list will come from another number of different areas. So there's a horizon scanning process that looks at new technologies coming through. Companies can put forward their different interventions to be considered. And then there'll be panels that decide which ones go forward. Also, politicians can put them in, unsurprisingly, to be decided upon. And then there'll be a nice committee that prioritise in coordinating with the Department of Health and the government to decide which ones are done. Do they share annual reports? When you say do they share annual reports of what the outcomes of them, or the ones that are selected?
Do you know how do you know how every private sector company they have annual reports of what their priorities are within the organization, gives you financial insights? I'm assuming NHS and NICE, they do individual ones for themselves, or like you said, there's a NICE committee, so maybe it's joint. I'm not sure.
I think there are elements of it will be in the public domain, and elements won't be in the public domain associated with things, particularly where there are politically sensitive decisions being made associated with them. So the Department of Health has numerous sets of priorities that are emphasised a lot of the time, but there's lots of things around pressure groups and industry, as it were, to put forward, because it's a really NICE guidance is a really important marketing tool for industry.
Yeah. Okay. These politicians, honestly. But thank you.
Sorry, can I just ask a quick question?
Yeah, sure, man.
Yeah, sorry. Thanks, Andy. In the table that you described based on the ICER, the organization decide whether to recommend or not. The last one, I didn't fully understand. Could you please describe that again? The ICER below 20,000, it said, I think.
Do you know which table?
The slide which recommends based on the ICER values
I don't think it was a table I picked up on that. It was when you were saying about willingness to pay, I think it was.
Yeah, willingness to pay, I think. Yeah, sorry.
No, it's fine. I picked up on that as well. I was a bit like...
So was it
this one? Yeah, sorry. This one, the third one, I didn't fully understand. I probably reasonably understand the first and second one, but I didn't fully understand the third one. Could you just...
I wonder if I put in whether it should be above 20,000. Not to recommend, normally based on plausibility of inputs, you can make an evaluation. No, I can't explain why. I'll have to check. I have to check back as to whether that should be above £20,000 per quality.
Yeah, that's what I was wondering, but because I didn't understand fully, that's why I wanted to check with you.
Yeah. It must be a typo. My apologies.
Oh, okay, sure.
But thank you for spotting it, both of you.
Thanks, Pat.
Thank you. Any other questions? Right, okay, I'll share my slides then. Right, can you all see it?
Yeah.
Okay, great, thank you. So, cost effectiveness acceptability curve. Now, what we're trying to do with this figure here is to try and start thinking about uncertainty around the willingness to pay threshold. As Andy was saying before, we have a threshold which is defined by NICE between 20 and 30,000 pounds per quality gained. Is not really a fixed rule, so there could be some leeway in terms of this threshold. So with this graph, we're trying to understand, okay, what if we modify the threshold? What is the probability of the intervention being cost effective at different willingness to pay thresholds? Now, this figure comes again from the article on advanced Parkinson's disease. And if we look at the vertical axis, we got the likelihood of the intervention being cost effective. And on horizontal axis, we got the ICER willingness to pay threshold. And as you can see, the ICER willingness to pay threshold is expressed in pounds, so £0, 20,000, 40,000, and so on. And the likelihood of the intervention being cost effective is expressed in percentages. So if we look at the point where the curve, its vertical axis, is about 17%. So that means if we have a willingness to pay which is equal to 0, so that means we don't have any budget at all, there is a 17% probability of the intervention being cost saving. So there is a 17% probability that we will save money by implementing the intervention. As we increase the budget, or as we increase our willingness to pay threshold, let's say, the probability of intervention being cost effective increases and increases and increases. So in particular, for nice threshold, at £20,000, the probability of the intervention being cost effective is about 40%. At £30,000, the probability of intervention being cost effective is 55%. And then if we have a even larger threshold, then the probability will be even bigger. Now, this curve helps us understanding how the probability of the intervention being cost effective changes with different thresholds. It's not always the case that the curve is increasing like this. It could be also decreasing, right? For example, if you have an intervention which is cheaper but less effective than the comparator, it could start from here, for example, and then decrease as we increase the willingness to pay threshold. That's why, for example, if this intervention is cheaper than the comparator, you know, as we increase our willingness to pay threshold, the comparator will be more and more affordable. So we will be able to accept it as an intervention. Any questions on this curve? Okay. There is a relationship between this curve and the cost effectiveness plane. Okay. When we see a curve which is increasing like this, which is very common, is because we are lying on the northeast quadrant. In the other example I was mentioning before, if we see a curve which is decreasing, we probably lie on the southwest quadrant, right? So there is a relationship between the curve and the cost effectiveness plane. I will describe a bit more this relationship later on. By talking about the cost effectiveness acceptability curve, we are now starting to consider uncertainty around some of the elements of our economic evaluation. In particular, we consider uncertainty around the willingness to pay threshold. But there are different types of uncertainty which we need to consider in economic evaluation. The first one is variability, which means unexplained difference between people in the sample. So people might respond differently to treatment due to genetic factors which might not be measurable. Heterogeneity, which refers to explainable differences between people in the sample. Again, there might be different responses to treatment by age, gender, and so on. So things that we could measure and we could perform a subgroup analysis based on these different variables. Parameter uncertainty, which means analyzing the impact of changing the values of the parameters. So in a clinical study, typically is a kind of an ideal scenario where you have ideal conditions where everything is controlled very well and very precisely. So the cost and outcomes you will see emerging from a clinical study, they might be not so representative of what happens in real life. So it's important to modify and to understand how modifying costs and outcomes will have an impact on the ICER, for example. Okay, the cost might be lower or higher in the real world. The outcomes might be lower or higher in the real world. So modifying the values to the parameters will probably have an impact on the ICER, and it's important we understand whether this impact is negligible or maybe non-negligible. And the most probably complex form of uncertainty is the structural uncertainty, because that implies understanding how changing the models of assumption will have an impact on the results. So, for example, changing the type of model. moving from a decision tree to a Markov model, okay? Including or excluding different comparators, including or excluding different health states. So these are things Luis, for example, discussed in sessions 2, you know, adding or removing health states from a particular model. Okay, any questions before I leave this to Andy? Okay, Andy, over to you.
I assume that's come up as a Valeria.
Yes, thank you.
So as Valeria's been through this, talking about the different types of variability, etc. If I move on to how we go, and one of the ways we go about trying to look at how we characterize uncertainty around the different forms of analysis. So there's deterministic sensitivity analysis, which basically looks at how, if you change a parameter or several parameters together, what sort of effect that has on the outcome associated with it. And normally that's set by providing an indication before you start the analysis of how you're going to do it, whether it's by varying it by proportion or quite what it is, as it were. Pardon me. And the way you rerun the models, changing these different parameters one at a time or several at a time to see what effect they have, but to actually look at how you can see what variables are determining the uncertainty in the model. You can do things such as this, which is produce a tornado plot around it. So this is looking at an analysis that was the ICA model that I was talking about for diagnosing dementia within it. So as you can see on the tornado plot there, you can look at the effect on the net monetary benefit of varying all these different parameters down here to see which ones are the most important in terms of the uncertainty around them. And as you can see, this one, the bigger the difference, the bigger the effect within it in terms of both the low values, which are in the red, and the high values, which are in the green there. So if you produced a plot like this, you'd know that the ones with the biggest variability, the ones that you need to look at and try and find out more about to try and understand that relationship within it. Got another one. Yeah, this is just another tornado plot, which again illustrates it probably a bit easier to see than the previous one within it. And this was from an evaluation that was looking at a particular drug and ran all the different variety there to find out what was the effect on the ISA. But as I say, you can run them either single ones, or you can single parameters, or you can run multiple parameters within that. That was a very short one, and now back to Valeria.
Thank you, Andy. I'll share my slides again. Any questions? Okay. So the last form of sensitivity analysis we're going to discuss today is the probabilistic sensitivity analysis, which differs from the deterministic sensitivity analysis, which Andy was describing just a few seconds ago, because it is based on the distributions of the parameters, on the statistical distributions of the parameters. I will show you some graphs here, and I'm going to try to talk through what we mean with distribution. Right, so here you got some graphs which come from this article on breast cancer in women aged 70 years or older. I wouldn't focus on the acronyms here, on the name of intervention. Let's just focus on the actual graph. So on graph A, you got the costs, graph B for the intervention, in graph B, you got the cost for the comparator. Graph D, you got the quality for the intervention, and graph E, the quality for the comparator. Okay. So when you do a base case analysis, you typically focus on the most likely set of input values or assumptions. So we could probably say that we focus on the average values, let's say, which might be like here in terms of the costs, somewhere here in terms of the qualities. Okay, so you focus on a really selected, let's say, sub-range of your qualities values or your cost values. But if you look at these graphs here, these graphs will depict all the plausible values that cost can take in the real world, and the same for qualities, all the plausible set of values that the qualities can take in the real world. And there is quite a good variability here. Now, the most likely value will be the one in the middle here, for example, for cost, which is associated with a probability or a likelihood of about 18%, something like that. Not so likely, okay, for example, here or here. The same for qualities. You know, you got values in the middle, which are quite likely, and other values at the right tail, or sorry, at the left tail or at the right tail, which are not so likely. And as I said before, with the base case analysis, we take into consideration what happens in the center, let's say, for the average values. But it's important to consider that in the real world, we might observe values like here, and so on. And with a probabilistic sensitivity analysis, we are able to characterize this plausible range of values, and we take into consideration values at the left end of this graph, at the right end of this graph as well. How do we do that? Well, we take different combinations of cost and qualities at the same time, and we basically do a random draw of these different combinations. So, for example, you could extract a random value here for cost, a random value here for qualities, and you carry on, and you do this random draw thousands of times using software. And in this way, you can map different combinations of cost and qualities together. And that allows you to understand what happens beyond the average level of your input values, okay? Because there is a plausibility, there is a likelihood that the average might not be so representative. You might find in the real world you've got different values. So you want to understand what are the impacts of considering these different values on your final results. So this is what we call a probability distribution for a specific variable like a cost and a quality. Now we bring everything together by looking at this graph here. Here we got different cost effectiveness pairs. So on the vertical axis, you got the incremental costs, and on the horizontal axis, you got incremental qualities. So if you take this point here, that means the intervention is more expensive, probably around £150,000 more expensive. At the same time, is more effective. It produces about 1.5 more qualities than the comparator, okay? The same reasoning for this point here. Is more effective, it produces more than 1.5 qualities than the comparator, and at the same time, it's cheaper because it's probably £100,000 cheaper than the comparator. And you could apply all the same reasoning for the different cost-effectiveness pairs. Now, what is important to consider here is where all these cost-effectiveness pairs lie in the most part. And you can see they lie in the northeast quadrant. So the base case analysis for this article, for the advanced Parkinson's disease article, was saying that we were lying in the northeast quadrant, so the intervention was more effective but more expensive. And the probabilistic sensitivity analysis seems to say the same thing, like most of the cost effectiveness pairs are in the northeast quadrant, but there is also a non-negligible quantity of cost effectiveness pairs which lie in the southeast quadrant. And the proportion of pairs which lie below the horizontal axis will give you the probability of the intervention being cost effective when our willingness to pay is 0. So if we go back to the cost effectiveness accessibility curve, you will probably remember that we had a probability of the intervention being cost effective of 17% when the willingness to pay was 0. And that 17% is given by the proportion of cost effectiveness pairs which are below the horizontal axis. So again, there is a relationship between this graph and the cost effectiveness plane and the cost effectiveness acceptability curve. As I said before, all these pairs come from a randomly drawing values from the cost distribution, the quality distribution. So if you do that thousands of times, sometimes 10,000 of times, you will obtain more and more pairs, and then you will try to see where they lie for the most part. It's kind of mapping all the plausible values in terms of cost and effects and try to see where they lie in the plane. Okay. Yes, Ruben, yes. So Monte Carlo simulation will be something, will be a form of probabilistic sensitivity analysis, yeah. Any other questions? Okay. So probably, well, at the workshop, right, we will look at the results more in detail, yeah. So your team lead will be able to show you a bit more the results from your specific paper in detail, and you know, we will try to understand the results together and try to answer any questions. So probably that will be a good opportunity to look at the results more in detail. Okay. Having said that, the homework for today is all based on the interpretation of the results from your specific paper. So you will have an opportunity to exercise yourself in terms of interpreting the results and then check with your team lead whether your interpretation is correct or not.
It's just that
any other? Yeah.
Sorry, yeah. I've just finished my master's, haven't I? And there's like scope to do an economic evaluation in that area. So that's what I was kind of thinking.
So you mean like separate from this course? So,
yeah, will there be like any separate workshop?
Yeah. Okay. If you, I'll drop you an email later. But yeah, I might signpost you to some opportunities if that's okay.
Thank you. Yes, that's
fine. Any other questions? Oh, any other points? Okay. So this is just to show you how we wrote up the info and the analysis and the results from that article on advanced Parkinson's disease. I'm not going to read it all. I'm just going to show you that we try to divide our summary in different paragraphs, let's say, one for the base case analysis, another one talking about the incremental cost effectiveness ratio, and then the cost effectiveness acceptability curve. And then we also try to focus on the deterministic one-way sensitivity analysis, scenario analysis, and probabilistic sensitivity analysis. You can have a look at that in your own time. But the writing up is really a task for the team leads, you know, so you will have opportunity to review how the team leads summarized and brought up the info and analysis and the results after the end of the course. Okay, homework for today is to answer 3 questions on the interpretation of the results from your own paper. These questions are based on the tables and the figures provided by the authors in the economic evaluation, and we're going to ask you to complete this task by next session, so Monday, 27th of January. You can access the document by going on section 5 folder, and then you will see a document with your name. And then you can open the document. There will be 3 questions regarding the interpretation of the results from your own specific economic evaluation. So this is it for today. And the next session, as I was mentioning at the beginning, is the last online session. And we're going to talk about the introduction section. I'm going to describe what to expect at the workshop. So it's going to be a shorter session. So if you have any outstanding questions from the course, you want to send us by email, we can discuss them at the session. Or if you want to think about questions, please bring them at the session, and we can discuss them there and then. So it's really there is time for a Q&A session on Monday the 27th, so we can discuss any outstanding questions together. Okay, and that's it for today. So I just want to thank again for attending, for all the questions and the points. Really interesting, and it's really good to see so much debate about these topics. And I want to thank Andy for co-running this session with me. Thank you very much, everyone.